Welcome to CSC 201, Lesson 9.1, Introduction to Probability. What is the probability of flipping heads 2 times in a row? We're flipping a coin. If you flip it twice in a row, what's the probability that you get heads both times? So the first thing we're going to do is we're going to count all the possible outcomes when we flip a coin twice using what's called a tree diagram. So we start at the root of the tree. Okay, this is like before we've done any coin flipping. And then when we flip the coin the first time, we have 2 options. We could get heads or we could get tails. And these are branches of the tree, 2 branches of the tree. All right, and then if we flip heads the first time, on our second flip, again, we could get heads or we could get tails. And if we flip tails, on the second flip, we could get heads or we could get tails. So each branch of the tree represents an outcome. So we've got heads, heads, or heads, tails. Then we have tails, heads, or tails, tails. So all possible outcomes are heads, 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 tails, tails, heads, or tails, tails. And this list of all possible outcomes in any given situation, this one included, is called the sample space. Now, if all of your outcomes are equally likely, as it is in the case with flipping 2 coins, right? Each of these is an equally likely outcome because assuming the coin is unweighted. And if we have a finite sample space, like we do in this example, then the probability of some event E, denoted P parentheses E, like probability of E, is the number of outcomes in E divided by the total number of outcomes in S, the sample space. And some notation for that is N of E, the number of outcomes in E and the number of outcomes in S. So what is the probability of flipping 2 heads in a row? The probability of HH, according to the equally likely probability formula, we take the number of outcomes in the sample space, which in this case is 1, 2, 3, 4 possible outcomes. And one of them is heads, heads. So we put 1 over 4, which is a 25% probability. And what is the probability of flipping 1 heads and 1 tails in any order? So that is, we want to find the probability of heads, tails, or tails, heads. Okay, so out of 4 total possibilities for the outcomes, 2 of them have 1 heads and 1 tails. So 2 out of 4 of the possibilities, or 50% probability. Okay, shifting away from the coin tossing, what is the probability of selecting a multiple of 3 between 5 and 21 inclusive? So I'm first just going to list all the numbers from 5 to 21. It's not that long a list, so it's just going to help us wrap our brains around what's happening here. So just write them all down. Okay, how many, well, let's see, the probability of selecting a multiple of 3. The probability that we get a multiple of 3 would be a ratio, and the numerator is the number of multiples of 3 in the list, and the denominator is going to be the number of numbers in the list. So the number of multiples of 3 goes in the numerator, and in the denominator is the entire sample space, the total number of numbers. So we can just count up the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 numbers in the list. And we should make careful note here that if you had tried to do that in your head and not just like pointed to each number and counted, you might have been tempted to do 21 minus 5, which would give you 16, which is the distance between 21 and 5. Like that's how many spaces there are between the numbers. But if you want to actually count the integers, counting this first number makes it one larger. So we're going to put a little note here. The number of numbers was 21 minus 5 plus one more. And that's how you always do that. You can just count them out, but if you wanted to use subtraction, you have to remember to add 1 to the difference between the first number and the last number. Okay, so now I want to count the multiples of 3. So multiples of 3, I've got 6, 9, 12, 15, 18, and 21. So that's 1, 2, 3, 4, 5, 6 multiples of 3. So 6 out of 17 is the probability of selecting a multiple of 3 at random from the list 5 to 21. And you can change it to a decimal or a percent. These are all equivalent. It doesn't matter. A jar contains 2 red balls denoted R1 and R2 and 1 white ball denoted W. One ball is drawn, its color recorded, and it is replaced in the jar. Then another ball is drawn and its color recorded. Draw a tree diagram to determine all possible outcomes of the experiment. So, tree diagram, we start with the root of the tree. Have not taken any balls out of the jar yet. And there are 3 possibilities for the first ball withdrawn from the jar, right? So I've got R1, R2, or W. Those are the 3 possibilities when I pick my first ball out of the jar. It could be R1, R2, or W. And then I'm going to put that ball back in. And then after I've picked my first ball, if it was R1, my second ball I could draw could be R1 again because I put it back in. Or I could get R2, or I could get W. And if I chose R2 as my first choice, I could get R1 or R2 or W. And if I chose W first, I could get R1, R2, or W as my second choice. Each tree represents an outcome. So each branch of the tree, so R1 is one branch. R1, R2 is another. So following each branch, R1, 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 R2, R1, W. So those are 3 possible outcomes that you get by following the branches of the tree. And all of my possible outcomes, let's just list them out. I have R1 followed by R1, or R1 followed by R2, or R1 followed by W. Then I can have R2 followed by R1, R2, R2, or R2, W. And then following the third main branch down its 2 sub-branches, I have W, R1, W, R2, and W, R3. Whoops, it's not WR3, it's WW. There is no R3. Okay, so those are all the possible outcomes. It looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possible branches. Therefore, what is the probability that both balls drawn are red? So the probability that they are both red. Well, it's going to be a fraction, and it's going to have total outcomes on the bottom, total possible outcomes on the bottom, and the top is going to be the number of outcomes with 2 reds divided by the total outcomes possible. So we already discussed how many outcomes are possible. That's 9. And how many of those outcomes have 2 reds, where we pulled 2 reds out of the jar? So let's see. This one is red, red. This one's got 2 reds. The next one is a red and a white, so that's not one. And then I have 2 reds here. I have 2 reds here. That's got a white. The rest of them all have a white in them. So it looks like 4 of my 9 outcomes have 2 reds. So my probability that both balls drawn are red is 4 out of 9.